Welcome to our senior secondary physics. In this video, we're going to continue with the topic measurements. We're going to concentrate on the subtopics length and time. So we start with the topic map. So in the previous two videos, we looked at introduction to measurements and prefixes. So prefixes were just an extension of introduction to measurements. In this, we learned some physical quantities. Two of them were length and time. So in this video, we're going to look at length and time. Let's get started. So we learned in the last videos that the SI unit for length is meters. We also learned that as a type of quantity, length is a scalar quantity, which means it has nothing to do with direction. But what instrument can we use to measure length? One of the common instruments used is a meter rule. There are some other instruments that are used to measure length. The table here gives us information pertaining to the instruments. So these are the examples of the instruments. This is the type of length they measure. This is accuracy. Accuracy is more like the smallest length they can measure. So there are some instruments which cannot measure beyond 1 millimeters, which means if given an object whose length is less than 1 millimeters, they cannot measure that. So this is what accuracy entails. We also have got examples of objects which can be measured by a specific instrument. So I'll start with the measuring tape. So of course, measuring tape is used to measure long length, and the accuracy is 1 millimeters, which means the smallest length you can measure is 1 millimeters. Examples, of course, are length of classroom, height of building, and the likes. Also, I've got the rule, which measures medium length, and of course, the accuracy is just the same as the measuring tape. And examples of objects include width of a paper, length of a pen. We have got an instrument called a Vernier caliper. So this is used to measure short length. Accuracy is 0.1 millimeters, which means it cannot measure below 0.1 millimeters. Examples of objects that can be measured include diameter of a pen. So diameter is okay. I'll explain what diameter is later, but just know diameter of a pen, internal diameter of a tube. So these are very important: diameter of a pen and internal diameter of a tube. I'll explain in details what we are supposed to learn from here. Also, I've got a micrometer screw gauge which measures very short length. So Vernier calipers measures short length, while micrometer screw gauge measures very short length, and the accuracy is very small, 0.01 millimeters. Maybe saying the accuracy is very small might not make sense, but what I mean is the smallest length it can measure is 0.01 millimeters. Examples of objects that can be measured using a micrometer screw gauge include diameter of hair. So you get a hair strand, you can measure it with a micrometer screw gauge. Thickness of a razor blade, so we use a micrometer screw gauge. So we're going to start with a Vernier calipers. We're not going to take a look at a meter rule because I think all of us know how to use a meter rule. So what is a Vernier calipers? How does it look? So a Vernier calipers looks like this. So if you take a closer look, you see that there are some measurements here and here. We'll discuss how to use these measurements. So we use these parts here and these for getting the actual measurement. These two are called outside jaws, while these two are called inside jaws. Why are these called outside and these ones are called inside? It's because of what they measure. Let's say we have got an object like this. We can slide it in here and we can use this screw or knob to lock this object. So when you are turning this, this can move either to the left, to the right, or to the left. The job is to make sure that this object we're measuring is locked. Once we do that, we can read from here. So at the end of the day, what we're going to measure? We're going to measure what is called external diameter. what is external diameter, or what is diameter, by the way. So diameter, given an object like this circular part here, the distance from one end of this part to the other is called diameter through the center. So external diameter is the distance from the external parts of this object to the other external parts. The opposite is internal diameter, which is the distance from the inner parts to the inner parts on the other end. So these two, by the way, these ones are called outside jaws because they measure the outside diameter or external diameter. The same applies to these. These are called inside jaws because they measure the inside diameter or the internal diameter. How do they do that? So if you have got an object, you can just slide the jaws into the object, inside the object. So you can use this screw to make sure that they lock. Once they do that, the reading that you're going to get from here is the internal diameter of this object. Now that we know how to we know various parts and how to use, or how the Vernier calipers measures the diameter of objects or the length of objects. How do we read from the Vernier calipers? And this is the most important part, because during an exam, questions are designed in such a way that the measurement has already been made. The job is to read. So there are two parts of this scale. There's this big one, which is called the main scale, and there's this smaller one here, which is called the Vernier scale. So how do we get information from this? To understand how to do that, I'll zoom in a bit somewhere here, so we can have something like this. So the reading on the bottom are the Vernier readings, and on top are the readings for the main scale. So how do we read? There are two steps to take. So the first one says, read the main scale reading, which is just before the 0 mark of the Vernier scale. So you go to the Vernier scale, you go where the 0 mark is, which is here. Then the reading just before the 0 mark, which is here, is the one that you are supposed to get. So there are two steps. The first one involves locating where the 0 is, going to the main scale, and identifying the value just before the 0. In this case, it's this. The question is, what number is this? So if you see here, this is 1 and this is 2. So how do we move from 1 to 2? What are the markings here? So normally we move like 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. That's how to move. 2.1, 2.2, just like that. So using that, what is the value here? So it's 1.1, 1.2. So the reading here is 1.2 centimeters. 1.2 centimeters. So we can write somewhere that the first reading we collected is 1.2 centimeters. The second step is look on the Vernier scale and find a marking that is in line with the marking on the main scale. Get this reading. So you go on the Vernier scale, you look for these markings. There's one which is in line with the markings on top. So it's this one. This one is in line. They are forming a straight line. So you get this reading. So this reading is 0.05 centimeters. That's how these readings are read. This is actually 0.00, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, just like that. That's how they are read. So this marking here, it's 0.05. So we can record that also, 0.05 centimeters. The final step is to add the two. So we can say 1.2 centimeters plus 0.05 centimeters. For those who are not familiar with how to add decimal numbers, we have to make sure that the points are in the same line. Like one is on this one is on top of the other. They have to be in the same line. Then the numbers you can write. Then to add, you'll be adding the numbers in the same line. Like this should be added to this. This should be added to this, just like that. If there is no number like here, then it means it's 0. So you're going to say 0 plus 5, which is going to give you 5. 2 plus 0, which is going to give you 2. and 1 plus 0 is going to give you 1, and you bring the point down. So we're going to have 1.25 centimeters. So this is how to read from a vernier caliper. So we're going to start. So we're going to finish the study of length by studying a micrometer screw gauge. So this is how it looks, and in the real one might appear like this. So this part here is called the frame, this here is called an anvil, this is called a spindle. And how the spindle works is you have got a ratchet knob here which you can turn, and it will be moving the spindle right, left. So you can insert your object here. Once you insert your object here, the spindle can lock the object in, and then you can use this lock to make sure that the locking stays intact. Then we've got here where we'll get our readings, and I will show you how this appears by going back to the simplistic drawing, which is this one. So this part here is the main scale, and one of the features to recognize from here is this line here, which is called datum line or center line. Then we've got this side here with the thimble scale, which is also called the vernier scale. So this is also where we get the readings. So if we zoom in on the main scale and the vernier scale, so this is how it might appear. But how do we get readings from here? So there are two steps to be followed. The first one says get the reading on the main scale just before the edge of the thimble. So this is the thimble, and its edge is here. So the reading just before this one, it is here. If this wasn't here, then it could have been this one, but it is here. What's the value here? So we can see that this is 3 and this is 4, and in between it must be 3.5. The same can be extended here. If this is 4, then this must be 4.5. So the readings on a micrometer screw gauge are stated in millimeters. They are in millimeters. Remember, micrometer screw gauge measure shorter length as compared to vernier calipers. Vernier calipers is centimeters, while micrometer screw gauge is millimeters. So we can record this as 4.5 millimeters. Then we can move to the thimble or the vernier scale. So how do you get the reading from here? So we look for a mark which is in line with the datum line on the main scale. And the rule says get the reading on the thimble that is in line with the horizontal line of the main scale. In this case, it is this one. What's the value of this one? So values here are in 0.01 millimeters. They show the movement from here to here, it's 0.01, here to here it's 0.01. So if this is 10, it must be okay, if this is 10, then this must be 9, and it is 0.09. I hope you get what I'm trying to say. They are read to the second decimal place. What it means is if this is 9, then you read it as 0.09, this is 0.08, 0.07, and here it's not here it's going to be 0.10, because 10 it will be 0.10. This is 0.09, so this has to be 0.10, 0.11, 0.12, 0.13, 0.14, and 15 is 0.15 millimeters. So in this case, what is this value here? So 0.9, 0.10, 0.11, 0.12, so it's 0.12 millimeters. So we can add these two to get 4.62 millimeters. So that's the reading. So we can now take a look at time. So we're going to start one instrument that is used to measure time, and it's called the pendulum. Other instruments which I am sure you're familiar with include clock, watch, stopwatch, and of course the pendulum that we're going to study. Of course, you're not familiar with the pendulum. I don't know why I included it here. Yeah, but of course you are familiar with the clock, watch, and stopwatch. The pendulum is the one we're going to study. The units that are used for time, we already studied, of course, include seconds. The other ways in which the units can be written are in minutes, hours, days, years, just like that. Of course, time is a scalar quantity. So a pendulum is something that behaves like this. So what it does is the amount of movements it makes I used to calculate time. So this is a simplistic drawing of a pendulum. So they are not three, these are just snapshots in time. So at some point in time it was here, at another point it was here, and at another point it was here. So this is a string, so it is tied to this ball called bob, and somewhere where the pendulum is hanging. The distance from where the pendulum is hanging to the center of the bob, let's use this one. So the distance from here to here, or the length, is called length of the pendulum. So when a bob is moving, we say it is oscillating, and if it moves from point A to point B to point C and coming back to A, we say it has completed a period. So a defined period as the time taken for one complete oscillation. The formula for period is T equals T over N. By the way, complete oscillations, it means moving from here, then to there, and coming back to where it had started from. So what is T, the capital T and small t, what do they stand for? So the capital T is period, the small t is time, which is in seconds, and N is number of oscillations. One thing I need to emphasize on number of oscillations is if the bob moves from A to C and back to A, it's one oscillation. If it does this twice, it's 2 oscillations. But what if it moves from A to C, and where it is required of us to calculate the period? So the number of oscillation it has made when it has moved from A to C, but it's not back, it's half, because the complete journey is supposed to be there and coming back. So it's half, or 1 over 2, or 0.5. What if it moves from here to here just? Then the number of oscillations is 1 over 4. Why? Because it has just done 1 out of the 4 steps supposed to do. The 4 steps are 1, 2, 3, 4. But it has just done 1 movement, so it's 1 over 4. So what determines the period of the pendulum? So the first determinant is weight of the bob. So if the bob is heavier, it means to be making fast movements, and if it is not heavy, to be making slower movements, because it's not trying to fall down as quickly as it could if it was heavy. The other determinant is length of string. So the length of the string is this here. So if the string is longer, then it will be taking too much time for it to complete an oscillation. So these are the determinants of the period of a pendulum. The other parameter that we can measure, other than just the period itself, is frequency. Okay, so let me just move this. Okay, so frequency is number of periods per second. That's how frequency is defined, number of periods per second. And the formula is F, which is frequency, 1 over T, which is period. And the units are Hz or Hz. So if you know the frequency, it's just the same as you know the period, because you can use this formula to get the period or the frequency. So these are the 2 most important parameters that we calculate when we are dealing with pendulums. This marks the end of this video. In the next video, we're going to take a look at mass as the the last quantity on the standard quantities. Make sure you like, subscribe, and share. If there's anything you need clarification on, you can use the comment section, or you can get in touch with me. Otherwise, happy solving.